Okay, so this is an advanced Calc 2 problem. If you're in pre-calc or calc, this is going to go very, very fast. Just use this as an example of how I teach, but I'm going to be going triple speed because I can only have 5 minutes. All right, these are parametric equations. X equals 4 cosine squared 2t, y equals cotangent squared 3t plus 1 on the interval t equals 0 to pi over 3. Our points of interest are 0, 2, 3, 2, and 1, 1. We're trying to find the area under the curve between 0, 2, and 3, 2, and the arc length between 0, 2, and 1, 1. The corresponding t's for each of these 3 points are t over 4, pi over 4, pi over 12, and pi over 6. Okay, I'm looking at this problem here. Okay, this is basic pre-calculus, right? Our x value of 0, which we plug into our x equation. X equals 0 equals 4 cosine squared 2t. Solving for that, dividing by 4, taking the inverse cotangent, we have 2t equals pi over 2, or t equals pi over 4. Confirming the y value, we plug in pi over 4 into cotangent squared 3t plus 1 equals cotangent squared 3 pi over 4 plus 1, which is cosine squared over sine squared, square root of 2 over 2 squared over minus square root over 2 squared plus 1, which equals 2. Pause this video. I've skipped steps for the second 2 so you can get some pre-calculus practice. If you're uncomfortable with your unit circle and you're in Calc 2, I highly recommend you work through these problems and convince yourself that these answers are true, okay? But the points are t equals pi over 4, pi over 12, and pi over 6 respectively for here. Now, when we're looking at this graph, right, we're looking for the area under the graph between 0, 2 and 3, 2, and we're looking at the arc length of the graph between 0, 2 and 1, 1. Noting that our parametric equation gives us a direction from right to left. We normally think of it from left to right, and this is important when we're doing our limits of integration, okay? So, moving on, we have area, all right? Area of any integral is from a to b, f of x dx, or y dx. We can look at plugging in y and then dx, right? dx dt equals 8 cosine 2t, right, times the derivative of cosine 2t, which is minus sine 2t, times the derivative of 2t, which is 2, which gives us minus 16 cosine 2t sine 2t equals minus 8 sine 4t from the cosine 2 alpha identity from pre-calculus. dy dt can be solved in the same manner to get minus 6 cotangent 3t cosecant 2 3t. Again, this is pre-calculus level stuff. We're going to use this to plug it into the area. Okay, the area is from b to a, y dx, right? Cotangent squared 3t plus 1 times minus 8 sine 4t dt. From a, 0, 2 to b, 3, 2, which translates into t2, which is pi over 4, and t1, pi over 12, right? So for part A, pi over 4 and pi over 12. Noting that we switch the limits of integration, that eliminates the negative sign from Calc 1. We get pi over 12 to pi over 4, 8 sine 4t cosecant squared 3t dt, which gives us 3.6697. Now, the problem doesn't ask us to solve it. It just says to set up the equation because it's a very ugly integral. Okay, for arc length, we use the formula length equals from t1 to t2, dx dt squared plus dy dt squared dt, right? So we plug in dx dt from here, right, and dy dt. Giving us minus 8 sine 4t squared plus minus 6 cotangent 3t cosecant squared 3t squared. Giving us 64 sine squared 4t plus 36 cotangent squared 3t cosecant to the fourth 3t. All right, we can pull out a 4, giving us a 2 outside the radical, 16 sine squared 4t plus 9 cotangent squared 3t cosecant to the fourth 3t dt. From pi over 6 to pi over 4. Again, pi over 6 to pi over 4, right? Just from there to there, okay? Now these equations, right, when you solve this, again, the problem only asks to set up the simplified integral, but when you solve it, it comes out to 1.66906. Remember, when you're dealing with parametric equations, you have to keep your limits of integrations in check because you could be moving from right to left or left to right, okay? This is the same. Pi over 6 corresponds to the point. Pi over 6 corresponds to the point 1, 1, and pi over 4 corresponds to the point 0, 2 for the arc length. And for the area, we have pi over 4 and pi over 12. Look at all these videos, pause each slide to convince yourself of the steps, and this should be good.